guys, so we're doing another reaction today, actually two. This one's called more than a decomposition reaction. We're doing, excuse me, potassium chlorate and sodium chlorate to show that you can have predictability with one reaction based upon the radical, in this case, which is the chlorate. In both cases, we're going to react it with a sugar that's in a compound. We don't particularly care for licorice, so we're going to use that as our source of sugar today. And in both cases, oxygen is released, as you can see in the reaction here. When you decompose these two chlorates, you're going to get oxygen released. Just like in a previous lab that we did, you had the carbonate that, like copper 2 carbonate, when it released, when you decomposed it, it released carbon dioxide. So in another carbohydrate, you can get carbon dioxide as well. Well, I wanted you to see that in this reaction because two separate compounds, predictably, if you look on the reactivity series, as on your periodic table here, you can see that sodium is listed above potassium. So you would expect, based upon that position, for potassium to react more vigorously than sodium. So we're going to actually look at that today and see if there's any differences in that reaction. They're both going to release oxygen. They're both going to burn the sugar as we have here in the bottom. All right, so we're going to go ahead and get this set up, get it started. As you can see, we're going to add heat. That's going to be from our burner over here. So I'm going to go ahead and light that at this time. Okay, so we do have a combustion reaction here as well. We're going to add some additional oxygen, which of course makes more complete combustion of the fuel methane. So that's going to occur here. I've got this one listed as potassium with a K on it, and I've got these licorice material, and I'm going to put it in there in just a moment. I've got these just in case it gets stuck. These are wood splints, and I'll use the crucible tongs to push it down in there if I need to. And I may even let this drop in there if we have enough. There's exactly 10 grams of potassium chlorate in this one, as well as 10 grams in this one. They were measured out ahead of time. All right, so we're going to let this heat up for just a bit. It takes a few moments for it to melt it to the point that it starts to change into a liquid form. And then you'll also see bubbles start to form as well. So this will take just a few minutes as this is going on at this time. As you can see, there is already some liquefaction occurring as the crystalline structure is melted to create the liquid form, and which also releases the gas. One of the tests that we use as a test for the presence of oxygen is we take a splint like this and we'll light it and then let it get to the point that it's kind of a glowing ember, and then we'll blow it out and then insert it in the mouth of this test tube, and you should be able to relight it in the presence of pure oxygen. As you see, we are getting almost all of the crystalline form of potassium chlorate melted. Should be generating some oxygen to the point you see some bubbles occurring there. So I'm going to do a little quick test with this. I've got the wood splint here. I've got the pair of tongs, so I'm going to light the the wood splint with the burner. Let it burn for just a moment to get an ember, and then not quite reigniting, but that's, whoops, the flame went out. Let's light that again. Let's try that again. Try not to blow it out this time. See it glowing there? You bring it out of that, it doesn't glow as much brighter in there. More oxygen, almost to the point of burning. All right, so let's see what we got here. Okay, when this, see there? We got pure oxygen there now. All right, so I'm gonna take one of these capsules. Now we'll close the shield because we don't really want this to come back on us, and turn the vent hood on. It should glow pretty vigorously. You can see, obviously a very continued reaction there. So I'm gonna light this again. Oh, I turned it off. Silly me. There we go. Works better when you got fuel. So here the glass. All right, so we're going to do the same thing with the sodium over here. Put that over here. Making sure I got a good amount of. There we go. And again, it will take just a few moments. I'll set this one aside. Move your fuel panel there. You can see some of the residue of the salt that splattered on the back. That was not there in the beginning, so that's what's going on with that. And you can see the of incomplete combustion of some of the sugary compounds. But we got the same, looks like, thing going on over here with the sodium chlorate. Again, it's doing its thing. It's taking a few minutes to melt. This one, you can smell the.
It smells like burnt marshmallows.
It smells like burnt marshmallows. Okay. Got my lovely wife here. She's assisting me. Thank you, Lisa. And this one may be occurring a little bit slower, which I don't know. That may, I don't know if you can see that or not. It did have, when I noticed it, the compound did have a little bit more moisture in it. So I don't know if it's due to the age of the compound or not, and how many times it's been opened. But you do see bubbles starting to form. You do see some of the same evidences that the previous one had. I'm going to go ahead and get the wood splint again. And we're going to look for that same evidence that we had before, the presence of oxygen. As you can see, there is bubbles starting to form. Give it just a little bit longer. Patience isn't one of my virtues, but getting better at it. All right, so you see it glowing pretty well. Now, if this was just the regular atmosphere, you see how it dulls down when you get out into the room, presence of the same amount of oxygen. Now, if we go down there again, you can see there it burst into flames again. See, do it again. All right, so we're predicting the same thing. So let's see what happens. Shot out of there, actually. But you can see the salt residue again, and from the previous one, I'm going to turn the flame off. So, looks like they were very similar. So hopefully you enjoyed this little demonstration and you got to see a combustion reaction. If you look back again, you can see what took place here on the board. There were other compounds, carbohydrates, but for the simplicity of the equation, I chose to use sucrose, which is the sugar, and of course the oxygen, which came from both reactions, producing carbon dioxide and water in those reactions. Of course, in the same reaction vessel, we still had some residual potassium chloride in the potassium and sodium chloride, which is salt. But I hope you enjoyed this. Have a good day.